You are now listening to the Add 10 Gallons Concrete Podcast.
Wait, the answer was add 10 gallons?
Add 10 gallons.
My first thought was we got to put Acti-Gel in it.
Yeah, great.
Truck's on the way. On the way.
Yeah, okay. I've got two observations, neither of which are really educated or well thought out. Which are like most of my observations are.
There aren't a lot of problems on a job site that can't be solved with a sack full of biscuits.
Today's episode of the Add 10 Gallons Concrete Podcast is brought to you by Acti-Gel 208. Acti-Gel 208 is a high-performance additive for the concrete industry that is greatly beneficial to the producer. It enables them to increase the percentage of manufactured sand by up to 100% and completely replace all the natural sand in the mix. In areas where natural sand is scarce, inconsistent, and expensive, this provides a huge benefit to any ready-mix company out there. Benefits of manufactured sand and concrete include consistent air content, improved compaction, and increased density. Now, in the past, the downside of using manufactured sands was that they were hard to pump, hard to place, and hard to finish. Well, Acti-Gel 208 solves all those issues. By improving suspension, stability, and the quality of the cement paste in the mix, Acti-Gel overcomes the old issues with manufactured sand and leaves them behind. Let Acti-Gel 208 improve the quality of your mix while saving money on every yard you produce. For more information, visit us at actigel.com. That's ACTI-GEL.com.
Welcome in, ladies and gentlemen, to the Add 10 Gallons Concrete Podcast. We're back again. I'm Josh, joined as always by Paul and Joey Bell. How you guys doing?
Doing good, brother. This is the only reason I come into the office anymore, so
Word.
glad to see you.
Word. Joey, what's up there at the home office?
Yeah, everything's good. I'm just glad to be back recording. It seems like it's been forever since I've actually been a part of this thing. I've always been somewhere.
Yeah, no, for sure. Our content is being spaced out for sure, but it's for good reason. I mean, we're all over the place and we're doing good things and we're meeting some really interesting people and hearing a lot of good stories out there. And hopefully here in the near future, we got some more unique guests coming on, much like the one we have today. Luai Kurdi, he is the founder and CEO of Print 4D. And boys, we've done this a few times before, but in this particular instance, I'm very proud of ourselves because for the last 3 or 4 episodes, we have mentioned 3D concrete printing in some aspect. And now we finally got an expert on here to tell us about it.
Yeah, I don't think people really understand. Like, we've been trying to record this podcast for, like, weeks. Like,
At least 2, yeah.
We've had this interview in the hopper, and we couldn't get together to do the current events segment. We tried doing it from, like, different locations. We're like, hey, are you available? Like, we'll just do it from your house. Like, who cares? Like, we need to get this out. No, nobody's available. Josh is working nights. Joey's working days. I was off, and then it's like, okay, well, now I'm available. It's okay, well, I'm working nights. Joey's working, nights. It was crazy. Nobody was available. It was the most insane schedule. Here we are, finally.
It is now officially night pour season, so I got that going for me.
You worked 3 nights last week. Awful.
Well, you don't sleep anyway, Josh. I mean, you can either spend your night at the garage working on something or you can spend it at the concrete plant. Just take your pick.
Yeah, sometimes it's both.
Yeah, the last job was like a half hour from his garage, so he just did both.
Yep.
It's that time of year where I'm doing stuff for other people, getting tires and carts and stuff ready. I'm doing my own stuff. Trying to look for a bigger shop space because I'm doing more powder coating stuff. And
what about that shop next to you? That wasn't enough.
They won't open it up for me. They're
they won't take the wall down.
Yeah, they're real slow about giving me the space I need. So now I'm trying to look elsewhere, and as in life, whether you're talking about a car or a house or a shop or a trailer, you never have enough space. Whatever space you have, you'll fill it up and then some. So that's where I'm at, where I need more space to become more efficient in my time as it pertains to powder coating and racing and all that stuff. So when I get to the shop, I'm not spending most of my time organizing, cleaning, setting up, that kind of stuff.
But that's interesting.
Yeah, once I get all that stuff set up, maybe I'll be able to pump some more work out. But the powder coating hobby is taking over
Is
my
it really?
life. Yes.
Wow. Well, at least that one makes you money.
Yes.
Did you go racing this weekend?
I worked at a track on Saturday as a race director, just like a local deal.
Okay.
And then I went there on Sunday to scuff tires. That is literally like whether they're new tires or you've used them before, tires age over time. They become harder on the surface, and depending on the construction of the tire, you can affect the sidewall stiffness by how many laps you put on it, basically putting a heat cycle through it and activating the chemicals within the rubber. You get it up to the heat range, and it changes the composition of the rubber. So with go-kart tires, you cycle your tires with age, thickness, date, how many laps are on them. So every once in a while, you need to go out to a racetrack and put 5 to 10 practice laps on about a dozen set of tires.
And that's what. So you weren't racing?
Nope. I went to a racetrack and just turned about 200 laps all by myself, just so I have a better tire inventory when I do go to race.
Look, I want people listening to this to know how much value we're bringing to your life right now. You came for a concrete podcast.
Yeah.
But you were leaving smarter about go-karts.
I don't know how much of this I'm going to keep in, but we'll...
What? No, that was great.
Yeah. That's my life, guys, just in case you thought your life was boring as hell.
What'd you do this weekend? Well, I drove in circles by myself.
Hey, I ain't even. I'm not even going to get into my hobby, which is wandering around miles deep in the woods, shooting a bird that you can buy at Kroger.
Yeah.
Yeah, but I told you last week, the picture you posted online of you and your baby, and y'all are sitting there next to that dead bird. That's the happiest I've ever seen her in her 2 years on this earth, was sitting next to her dad next to the dead bird.
Yep. Turns out it's genetic.
Yeah. She can't help it.
What did she say to the dead turkey? What was her phrase?
Oh, so she tries to say turkey, but she can't say turkey, of course. She says tut-tut. And so I forget what it was. Like one day we were like leaving the house, or it was bath time. We were leaving the living room, and I have this statuette, I guess you would call it, of like two bronze turkeys, from National Wild Turkey Federation. And whatever we were doing, we were leaving. She just turned to that bronze statuette. She just said, "Bye, tut tut." And so ever since then, she'll say "Bye, tut tut," randomly. So I was like, that's probably going to be what I say before I squeeze the trigger from now on. Bye, tut tut.
That's hilarious.
Well, while y'all were doing that, I spent the weekend in Birmingham, Alabama, and we went back for my dad's memorial. So that was great. Our whole family. For people that didn't know, my dad passed away recently, and he was the 11th of 12 kids.
Phew.
Wow.
And he was 56 years old when he passed. And so his oldest brother is 72. And
wow.
Everybody just doesn't get together anymore. I mean, I had cousins at this memorial that I hadn't seen in 20 years. Legitimately. Maybe 25. A long, long time. Because everybody moves off and comes back and stuff.
Yeah.
But they were all there. I mean, it was crazy. And the Finley family is one of the most dysfunctional crews I've ever met. And everybody was on their best behavior, had good food. It was unbelievable. It was actually, normally you think, oh, man, your dad died. You had to, go have a memorial. This is horrible. It was, one of the greatest weekends I've had in a long time.
That's good,
Just
man.
Seeing all the family and everybody actually, being cool. Got to show my daughter to everybody because, none of them had hardly met her, because we live up here, not in Alabama. But that was cool, man. Birmingham was cool.
Did your fiance go down there with you?
Yeah, she did too. So everybody got to meet her, and so a lot of those people had gotten wedding invitations and stuff. And I didn't expect any of them to say they were going to come because it's a long way away for them. It's a heck of a drive. Plane tickets are insane right now.
They are.
But man, we've got half the family. I couldn't believe it. How many people are like, yeah, we're coming. Pack in the car, make a week out of it.
Nice.
Well, all right.
So I've gotta ask. Well, one, was it her first time in Alabama? And two, if so, what were her thoughts of her first trip to Alabama?
Second time. First time really staying. So I made sure to take her and let her stay in the nicer part of town. The side of town that doesn't smell funny. The only thing that makes her laugh about Birmingham is she's grew up in Philadelphia, which is a big city with tons of history.
Mm-hmm.
And so when she goes to Birmingham, she's like, this is it? This is the city? This is the whole thing? The whole thing right here. Those two buildings, you know.
It's a big town, really.
Yeah, it's a town. It's like, yeah, here's what we got. She's like, whoa, you know, cool. Tell me about the history. I'm like, well, we got this thing called the Vulcan. And, you know, he shows us bare behind to half the city of Birmingham up on this hill. And she was like, okay. I was like, we have Nick Saban.
Checkmate.
You know, so she's real respectful about it, but at the same time, she's like, all right, that's cool. Good for you. And, you know, pat me on the head, you know.
But she hadn't seen, like, outside of the town of Birmingham. Like, she hadn't seen, like, real Alabama.
No, I didn't want her running away.
No, Joey, she's never been to Talladega.
I thought Talladega was like customs for Alabama. You had to go through there.
I didn't want to take her away and hear the banjos playing going down the river. You know, no, none of that.
Homeboy's getting into some actual concrete content. If you go a little bit further west of Alabama, but to an area where there is even less population, you will find.
Okay, that's a segue. I like it. Where are we going?
I was trying. That's as good as I could do. We're talking about 3D printing here today, and in El Paso, Texas, more specifically Fort Bliss in El Paso, Texas, the U.S. Department of Defense is currently undertaking a plan to print 3D concrete printed barracks. They're printing 3 of them, each one measuring 5,700 square foot. So a little bit larger than your standard 2-bedroom house that a lot of people think of when they think of concrete 3D printing. They announced the plan just a couple weeks ago. The article that I'm reading from was published yesterday. And this particular project will be the largest 3D printed structure in the Western Hemisphere. I mean, obviously it's not the Burj Khalifa or whatever they printed out there in Dubai. That was absolutely astronomical. But
yeah, but it's still cool. And if you go to Icon's the company that's going to build them, if you go to their website, and they've got some pretty cool write-ups about it.
Yeah.
It's going to look pretty cool.
Yeah, well, and I think the important thing to note here is the U.S. military is adopting the technology. I mean, I think that's the biggest takeaway here, and the fact that they're completing a 3D printed project for new barracks in less than 10 months, which for any government project to happen within less than a year, that's lightning fast.
Yeah. That's funny.
So that's pretty cool. And then, also staying in the state of Texas, but, talking about the actual residential part of it, Sun Economy is a fairly large company down in like the western part of Texas. And they're 3D printing like an entire, I guess you'd call block or cell of homes. And they're all, single family homes that they can print and complete in a day.
Oh my gosh.
So a 24-hour print cycle, and that gets you a 3-bedroom, 2-bathroom with a detached garage and solar and wind battery backup section within the house. It also comes complete with rainwater containment systems. And these houses will be sold for an estimated cost of about $289. Let's call it $300,000.
Yeah, cool. Who's the printer? Is that company the printer, or they're like the GC home builder?
They are the GC home builder.
Is Icon doing that?
Apis Core.
Apis Core. Okay, because I actually didn't see the article you're reading from. I was actually independently yesterday was looking at a different article about the DoD project with those army barracks. And I was on Icon's site, and they are also talking about building a 100 residential home neighborhood. Basically the same thing. I don't think the houses are that big, but similar concept. Going to go ahead and build a whole neighborhood of these 3D printed homes. And the thing that I thought was interesting is their idea is different from what I think is going to really blow this thing out of the water is they're not making the houses look traditional.
Right.
They're making the houses have curved exterior walls rather than sharp angles like we're used to houses being rectangles or almost like modular boxes. They're not doing that, and they're going to have the concrete exposed on the outside, and they're going to have a lot of wood elements. And I think that is interesting. I'm just concerned that you're limiting your buyer's market, that you're going to be going after people that are really, I want a novel house that is green, rather than saying, we can build you a normal house that's also green and 3D concrete printed. It just looks like a house. It doesn't have to look like, you went back to the Flintstone era to live, 'cause that's what they look like to me.
Yeah.
These curved walls, it reminds me of something Fred Flintstone would be walking into.
Yeah, straight up Pueblos or whatever.
yeah. I'm like, man, we could make these look so good. But, I don't know if it's because they want to, like, show off the art form or whatever. But yeah, just I think this is a great first step because, we're all about the technology. We want these guys to do well. I'm not trying to crap on them. I'm just saying, like, this is a cool first step. I can't wait for them to take that leap, and we can have things that look like houses.
Yeah, no, I hear you. But I mean, for that area of the country in West Texas, if you go north, I mean that's Tornado Alley, right? And they even talk about in this article. I mean, they're building homes that can withstand 220 mile an hour winds, E5 tornadoes, and 8.0 plus earthquakes and stuff like that. So,
Wow.
I mean, if you really want to stick it to the stick built industry, I mean, those are some stats that are going to be pretty hard to beat.
Mm-hmm.
Yeah, 100%. I was just in Birmingham. I was going to my buddy's new house, and the best feature in his house to me was the tornado shelter room.
Yeah.
He had a foot thick concrete walls of like a 5x5 area, and if a tornado's coming, I mean, that's where you go. That's going to be standing forever.
Right.
Well, I wonder if you have a concrete house, in Tornado Alley, how much easier is it is it easier to get tornado insurance or something like that? Like, hey, I have this house that can withstand all these things. What's my insurance rate going to look like versus the guy down the road that's got a stick house?
The answer is yes. I shouldn't say for Tornado Alley. I don't have the exact stats there, but down in southern Alabama on the panhandle of Florida, yes. So they have hurricane problems, and so the insurance companies, when you're building your house, if you build it out of concrete, you get like the highest rated this way, and they give you a discount on the insurance because the home's going to be there. It's going to be standing at the end. And in Alabama, I'll never forget, this was, I believe, 2011, when the 2011 tornadoes came through, which were just absolutely awful. April 27th, 2011, hundreds of tornadoes, a lot of them EF4 and EF5s, just ravaged the state of Alabama. And there was a neighborhood outside of Birmingham, and the entire neighborhood was gone. Just a pile of, what looked like toothpicks, because it was like an aerial photo. It was like 200 houses or something crazy, all gone but one. The one house in the neighborhood that was made out of concrete was still standing perfectly fine. All the other ones were just not there.
Yeah.
Wow.
Yep, that's pretty wild. So, yeah, I mean, eventually I think they'll catch up with the design elements and the aesthetics of it. But, I mean, you certainly can't knock the effectiveness of concrete houses, especially down there in Tornado Alley where they're really building them. Whether it's Apis Core, Icon, I mean, they all have a huge foothold down in that region of our country anyway. And with the adoption of the technology from our own government and their infinite amount of resources, there ain't no telling where the technology can go from there. But what else y'all got?
Well, I've got something interesting that our good friend and previous multi-episode guest of the pod, Dr. Belkowitz, he and I were chatting on the phone one day about some other things, and he told me to look up the Sand Mafia. Now, when he originally said Sand Mafia, I, of course, had my doubts, like, Sand Mafia? What in the world is this,
They're called the Taliban, guys.
My God. We're gonna have to give this a few minutes.
Add 10 after dark.
Add 10 after dark. Here we go. So when Dr. Belkowitz first told me about the sand mafia, I was like, what in the world is this nonsense? What kind of stuff is he cooked up now? But I looked into it, and it's actually pretty interesting. Actually, what the sand mafia is basically illegal strip mining of sand in India. There's actually a black market for sand, and it's legit like mafia, activity. There's extortion. The mafia miners, I guess you could call them. They've killed law enforcement officers that have tried to enforce, these laws about, over mining of the sand. They've killed journalists that are trying to expose and and put the message out there about everything that's going on. So how did it get to this? So we all know, or we know now, or I know after reading the article, that sand is in a lot of things. Just like when we started with active minerals, we had no idea clay was in so many industries. Well, sand's in everything too. Major product being glass. The glass in our smartphones has got sand in it, and all the list is endless of what sand is in. And there was a UN study not long ago that calculated the world's consumption of sand. And the world consumes 40 billion tons of sand every year. What difference does that make? Well, that 40 billion tons is actually double the amount that gets naturally replenished by the earth every year. Via, erosion, like from mountaintops, or flooding. Flooding will wash sand downriver to, whatever area where they're dredging. So it's getting to be a big deal. And we see that, of course, here in our work, just here in the States, where sand is getting scarce in certain areas. And just like here, everywhere else, river sand is the best sand. Desert sand is a little too round, for binding, and sometimes it's too fine. And then, of course, marine sand is too corrosive. So river sand's where it's at. So in India, they're having a real hard time supplying themselves with sand, and they're taking certain measures to try to limit the amount of mining of the sand. Well, this state, there's a state in India called, if I pronounce this right, Uttar Pradesh, pardon my Tennessee pronunciation of that state. They actually banned large-scale industrial mining of sand, but you can actually still have a manual mining operation, which they didn't really describe it in the article, but I can only imagine it's a bunch of old boys with picks and shovels and buckets.
Bunch of slave labor is what that's
yeah,
about.
Yep, so you're probably right. And the reason they're so concerned about, the over mining of sand is that stripping the rivers of their sand is causing the water tables to drop. So when you basically you dig a hole in a river or dig a giant section of river out, it's going to drop the water table, which may not seem like a big deal, but when you live in an arid area or region and your water table drops a couple of feet, that's a big deal. I mean, you're losing crops, you're losing ways to to grow things. And as we know too, sand is getting shipped enormous distances. Not just from Montgomery to Birmingham, like some of the guys we know down there, but Australia is shipping sand to Arabia, which is kind of hard to believe. Just like I mentioned earlier, though, desert sand, you can't really use that for a whole lot of things. So Australia is actually shipping good sand up to the Middle East. And China, there was a study done that between 2011 and 2014, they poured more concrete between 2011 and 2014 than the United States did in the entire 20th century. So that's how much sand that they're using.
They're building gigantic empty cities out in the middle of nowhere because that's what dictatorships do. They build big, great things.
What?
Yep.
Yeah.
What? They built an empty city.
Yeah, more or less.
For what?
The Olympics.
Are we about to have conspiracy corner
Nope.
with Josh Harris? No.
Nope.
Oh man,
Hold
we
on,
just
let's
laid it
take
out
a
for
turn.
you.
Paul, hang on. He teed that up.
Yep.
I need this to be hit out of the park. Wait a minute. Giant empty. All right, we're gonna get back to Josh in a second. Joey, please continue with this sand shipment story.
So, with China, being the number one consumer of pretty much everything on Earth, India ranked second in their sand consumption. It didn't give the data or how much that they're using, but that's what they're doing. Because of this ban on large scale sand mining, of course, that opened up the black market for sand. and it got so out of hand that it was, it was deadly, and people are killing people over sand. And it's not just that. Of course, with any kind of organized crime, you have to pay royalties to policemen, politicians, anybody with some power. And why that's important is the royalties to those politicians and police. They have inflated the price of illegal sand from 15,000 rupees a truckload, which is about $200. So it inflated it from $200 a truckload up to between $530 to $1,100 a truckload of sand. So yeah, thank you, Dr. Belkowitz, for turning me on to that. And I'm definitely going to look up some more articles, and maybe I'll find some videos about that. But yeah, the sand mafia in India.
Wow, that's crazy. But if you're going to allow manual mining, I mean, you're just asking for child labor, stuff like that. Just horrible stuff to be taken on, because they do that in other countries too, where they do the manual mining. And it sounds crazy to us because we're so used, like, oh, if it's going to be a mine, we're going to see all these big machines. But the one I always go back to is they get that big UFC fighter, Francis Ngannou, who's a heavyweight champion, and that's like what he grew up doing. He's 12 years old in sand mines, and that's how he got big and strong. I mean, it's just bananas that there's a sand mafia. That's so crazy.
All right, you ready for me? I got receipts.
I was born ready for this.
All right. I tried to cite a Wall Street Journal article, but I couldn't get past the paywall. So I'm reading you from a Wired article. Nonetheless, they're just as journalistic as the Wall Street Journal people are, let's be honest.
I would have gave you my login.
Title of this article is The Unreal Eerie Emptiness of China's Ghost Cities. Subtitle is Build It and They Will Come, except no one has. The Kangbashi district of Ordos, China, is a marvel of urban planning. There's 137 square miles of shining towers, futuristic architecture, pristine parks, all carved out of the grassland of Inner Mongolia. It's a thoroughly modern city, but no one lives there. It's one of hundreds, they state in this article, of sparkling new cities sitting relatively empty throughout China, built by a government eager to urbanize the country, but it's being shunned by people who either can't afford it or they're hesitant to leave the rural communities in which they live.
Hundreds of cities.
That's what they say.
There it goes. All right. I'm sorry, I gotta stop you for a second. I am 230 pages into the 320-page book, 1984, by George Orwell.
Yeah.
And
it's a good read.
One of the crazy things about that is that the government needed to continue to create things, but did not want to increase the standards of living and the availability of things for the people, so they could keep them relatively where they are, and as far as status and comfort and different things. So they had like never-ending war in that case. So the war machine was always going. It was always productive. So it gave people a sense of purpose, a sense of patriotism, a place to work. They were constantly consuming things, but it was never really going anywhere. It wasn't improving society. And so you're sitting here telling me that this communist country is churning out ghost cities so that they have a place for people to work, people to spend money, all this stuff. And I'm just over here like freaking out. I'm like, Orwell was right.
Yeah. He was right about a lot of things. Yeah, but apparently over the last 3 decades, China has built hundreds of new cities in an attempt to reshape itself into an urbanized nation, and the goal is to move about 250 million rural inhabitants, which is, 250 million is quite a bit. What's our total population? About 330?
330 million.
So, yeah.
Wow, that's crazy. And to think, they could have been buying Acti-Gel for all that. I don't care if anybody lives in it.
Exactly. As long as the check clears.
yeah, as long as the check clears, you ain't lying.
Which, yeah, apparently that is an issue. But yeah, just a quick search here I just typed in giant empty cities in China. And there's countless articles, and the pictures are absolutely jaw-dropping.
So you not only are like producing our podcast, you are also now Jamie from the Joe Rogan Show. You're also pull that up, man.
Man of many hats.
We do it all here at Active Minerals. Like we are 5 positions in one.
The only thing, one of these days, I want to get into a conversation about Smyrna Ready Mix.
Oh, just buying everything?
Buying everything. And that was a big news story last week that they just announced.
Everybody is talking about them too. Just like I was telling you, the guys in Las Vegas were talking about them. The guys in Chattanooga were talking about them last week too.
I was just on the phone with the NRMCA last week about something, and they were talking about them too.
Mm-hmm.
Maybe we should get into it then.
Yeah.
Let's make some waves.
They got to see something we don't, because the whole industry's talking about it. Guys have been making waves for about 5 years now, really making waves. The Hollingsheads have been buying anybody and everybody they can get their hands on. Started out just a couple plants in Middle Tennessee, and next thing you know, more than a decade later, these guys just own what seems like everybody. Big announcement got made recently that they bought the Martin Marietta properties, the Colorado division that was formerly Lafarge, and they bought what I believe are the San Antonio operations. But none of the announcements actually said which Martin Marietta plants were sold off. But we know a guy, and we think that's what it was, but can't confirm. So anyway, they did that. They bought some guy in like Wyoming, and the word on the street is these dudes at Smyrna Ready Mix, they want to have a plant in every state. They want to be all across the country. They've already got 4,000 employees. I mean, that's insane. A ready mix guy who started out as a mom and pop, still, family owned, has 4,000 employees. I think 4,500 now since, or 5,000. Their website says 5,000. The press release said 4,000. So, whatever. A lot of people. One of the big things that everybody wants to know is where are they getting the money for this? Because they're buying 20, 30 plants at a time. Yeah. And they're buying plants that, may not be the overproduction profitability centers that one company says they are. And they go in and they're like, don't care. We want them. And they're going in, they're making money. So I'm looking at this from the outside with a lot of other people. Y'all are talking to guys, and this is a hot topic because it feels like every month Smart is buying somebody. And what I can't understand, and I don't think anybody understands, we're like, man, there's some money behind this. Where's it coming from? And I started thinking, it may not be nefarious. Because sometimes it's just something we don't understand. And I kind of go back to a principle of finance. One of the things that one of the guys that I listen to being Dave Ramsey down in Tennessee. And, he says do everything with cash, right? So move at the speed of cash. And he said that if it takes a while to buy your first one, but once you've bought the first one and you use that cash flow to save to buy the next one, now you've got flash cash flow of 2 or 3 properties that allow you to more quickly save to buy the fourth. And now you got cash flow from 4 or 5 properties, and now you can more quickly buy the sixth. And if you actually go back to these guys and you actually look at like the timeline of how they built this company, it's entirely possible that if their only goal is growth, that they're cash flowing this, a lot of it. Maybe not all of it. I mean, it is the business world. People take on debt. Debt's been cheap the last few years. So I'm not saying there's no debt here. But that doesn't mean that they're leveraged up to their eyeballs. Mm-hmm. I mean, it's really interesting to go back and look, and it is a clear pattern. It feels to us like they came out of nowhere. A rocket ship to the moon, suddenly they own everything. But if you actually go back and look at the start of the company, it's actually a pretty slow growth. They had 1 plant, then 5 years later, they got 3 plants. 4 years later, they got a couple more plants. 3 years after that, they've got a couple more. 2 years after that, then 1 year after that, and then every year after that. And so it's actually almost like a perfect curve of what you would do if you were saving your money and like, okay, I'm going to put this toward buying things. So my guess is this has been a master plan for a long time. And I think that a lot of us have just seen, we think it's overnight.
Right.
And I don't think it's overnight. I think these guys are thinking this thing through. And this is speaking as someone who has zero knowledge. We are 1,000% speculating, like most people are. But just looking at that growth curve, I think these guys might be doing it the right way. and I'd love to talk to him further about it.
Yeah, we'll try to get somebody from that company on the show for our own personal benefit. It would make a great show, but like I want to talk to somebody from SRM for sure.
Because like you said, everybody's been talking about it, but
Yeah, everybody's thought is that there's like some outside investor with tons of money, or these guys have debt up to their eyeballs.
Yeah.
But knowing what I know from listening to Dave Ramsey all that time, you go back and look at how this company's grown, they might actually be doing this in a way that is, very, very, very smart.
Right. Or at the very least, not incurring 100% debt. Maybe they are cash flowing a portion of it.
Yeah, absolutely. They could be growing what seems crazy has actually been in the works for a long time.
Yeah.
And so if they've got cash flow coming in from all these other plants, man.
Yeah, well, with all that being said, we covered a lot. I mean, that was probably one of our more in-depth current event sections there. So without further ado, let's get into our guest here. We got Luai Kurdi. He is the founder and CEO of Print4D. Super excited. I nerded out over this interview, because I'm a 3D printer myself, but it's all like, plastic filament stuff, but the mechanics still apply. Whereas the 3D printing mechanics are way more, it's the same concept, but way more intricate. I got a 3D printer that's an X, Y, and Z axis, but they actually have a robotic arm type printer where they have a 6-axis printer instead of a 3-axis printer. And Luai, he goes into detail about that and many other things. And we berate him with questions, and he answers them very, very well, very knowledgeable, very succinctly. And it's a great interview. Can't wait for you guys to listen to it. So without any further ado, here's our guest, Luai Kurdi from Print4D. All right, ladies and gentlemen, today on the program we have Luai Kurdi from Print4D. We really appreciate you being here, Luai. How's it going?
Going good, thanks. Thanks for having me. Happy to be here.
Yeah, we're really ecstatic to have you on the program here today because for the last couple episodes we've talked about 3D printing at length, and none of us really know what we're talking about. So we needed to get an expert in here to talk about it. Backstory, I 3D print myself, but with your typical plastic filaments. I got a home unit, and it runs constantly. I'm always printing off that thing. So from what I know, it is specific to printing PLA plastic filaments all the way up through nylon filaments, but plastic nonetheless. And my build plate is 11 inches square. So we're going to take that concept and extrapolate it to printing concrete in large volumes, big enough to print something that you could actually live in. So somehow we're going to bridge that gap, and you're going to be here to help us do it.
All right, I'll do my best.
Right on. Well, first and foremost, let's give the listeners a little bit of background, a story on who you are, where you grew up, what your profession is, and what led you into the 3D printing concrete world.
Yep. Well, I'm an architect. I grew up in Jordan. That's my home country. I'm from the capital Amman, and basically I graduated from Jordan, and after that I left Jordan to do my master's, where I specialized in digital fabrication and advanced manufacturing techniques, where I got more into 3D printing. And ever since I left my home country, Jordan, I've remained outside of the country. I haven't lived there ever since then. That was around 8 years ago. So I've been traveling around, working in different countries, and actually to share with you a fact, for the past 10 years I've lived in 7 different countries. So traveling around a lot, learning from everywhere that I go, and kind of being introduced to new cultures, to new languages, and that's kind of something that I'm also interested in. So as I mentioned, I'm an architect, and then today I'm more focused on 3D concrete printing. I've been doing it for full time for the past 3 years, and basically as an architect, I really wanted to bridge the gap between design and fabrication. And that's where I saw 3D concrete printing is really the tool to do so. It opens up a lot of possibilities for architects and designers, and gives you the tools to do that. And basically, I think personally this is the future of construction.
Well, we've certainly heard that a lot. We've heard 3D printing is the future of construction. It will become a very useful tool to alleviate a lot of the labor shortages that a lot of these contracting and construction companies are being faced with. But there are many unknowns, and there are many things that need to be addressed before we can look at 3D printing as a viable option for everything, a fix-all for the industry, if you will. So talking about where 3D printing got its start. Well, let's talk about 3D printing in general. So 3D printing, the concept started in the 1980s. 1984, the STL file was invented, which is essentially the program that is used to talk to the software that slices in layers for the printer to actually print. Down the road, through the late 80s into the early 90s, things were, the technology was developing. The mid 90s, like 96 or 97, we figured out how to print with 3D print with metal. 99, we started printing 3D, started medical 3D printing. I believe it was at Wake Forest. They started printing scaffolds for bladders using human tissue to 3D print. And then, 2008, you had the first 3D printed prosthetic. And then 2019, you get the largest ever printed 3D concrete building in Dubai. Now, with your background, where does concrete fit in with that timeline? When was the concept kind of intertwined with the history of 3D printing in general, and how far has it come since then?
Yep. Well, actually, 3D printing for construction has been there since quite a long time. It was actually in the 1930s. You have in the US, actually, I think it's called the Urschel 3D printer, where they were using not the modern type of concrete, but a very similar material to construct buildings. So it's been there since the 1930s. But of course, some hurdles were faced for the technology and kind of got lost in the way. But then just recently, with the development of 3D printers and robotics, and of course with the new softwares that enable us to better control the printers and do more interesting designs with them. Because in the past, of course, the software was one of the biggest hurdles, because if you wanted to design a really complex and curvy wall element in concrete, for example, you would have to learn the programming language of a certain robot and kind of program it manually, and to create a complex geometry. That's not an easy task to do, even for an experienced programmer. So slowly the software started to catch up and make it a bit easier to communicate as an architect, a designer, with the robotics and the equipment. And that's when it kind of opened up the space for development of new technology. So we started using concrete in the additive manufacturing process, and then we moved it on to the next stages where we implemented it into the project.
Awesome. So as the software is improving and the methods are becoming, I don't want to say easier, but easier to replicate anyway, what was the original purpose for 3D printing as it relates to concrete? Was it for kind of an artistic, architectural design element, or was the purpose of concrete 3D printing always to build these massive residential or commercial structures? Or are they two very different industries that are under the same 3D printing umbrella?
Yeah, well, I think even like today, the largest 3D printers, the gantry, the main brand Cobot, is able to print 2-story high, maybe sometimes 3-story high, but it's still a small construction project if you compare it to a mall, for example, or a hospital or something like that. The technology is not there today to print at least in one go the whole large construction project. And the other approach would be, the one that I've been using personally, which is a modular construction approach, where we are using a robotic arm to 3D print modules, wall modules, that are easily prefabricated within a factory setting that can be shipped to the site. And in practice, the scale is not an issue here because you're printing modules. You can print as many modules as you want to create any space or enclosure. So this is where it's at today. The reason it started 3D printing, I think, one of the things was exploration of how can we create complex architecture with this technology, because of course with 3D printing you don't need to create a mold or fabricate a mold, which is typically a wooden mold or a steel mold that you would need to cast with concrete to achieve this kind of geometries. So with 3D printing, you eliminate that completely. So it cuts down the time to produce the same piece that you would have taken months to produce with a wooden mold. And then it started slowly shifting towards construction and how can we utilize it in a construction setting.
So obviously way before COVID, way before we got to a point of a diminishing labor force, and obviously the diminishing labor force was an issue before COVID, and then between 2019 and what we have today, everything that happened and transpired within that time just kind of accelerated an issue that we already had. But from what I understand through the modular approach and being able to prefab items, almost like hollow core pieces or tilt-up walls, the same concept, but being able to do that and to ship them to the job sites. Speaking personally, I look at 3D printing, then one of the main benefits is, well, you don't need as many people. You don't need as many people to batch the concrete, to place the concrete, so on and so forth. But from what I just understood, you can kind of take that one step further, and you can actually prefab pieces that previously weren't able to be prefabbed by just one person or one machine. So that modular approach, are you talking about making structural concrete pieces like a hollow core wall, or are you talking more about making like precast pieces, like decorative precast pieces or culverts? Or
actually, I've worked on all of those applications. I've covered all of them. I've printed all of these kind of applications. But what's more interesting for me, if we're talking about buildings and construction projects or houses, is a fully structural 3D printed wall element, where basically you can think about it as a Lego. You're printing the different modules. The full height of a wall can be 2 pieces, can be 3 pieces. It really depends on what you're trying to achieve and how high you want to go. And you can print these structural wall modules that can be assembled on site together, and that really allows you to eliminate the use of other reinforcement methods such as steel reinforcement. Because if you are printing a load-bearing wall system, you don't need a steel reinforcement column, or you don't need a column at all inside these walls, and you can transfer the loads directly from the roof to the walls.
that's incredible. You actually answered the next question was, is there steel in this concrete? But you're a step ahead of me. But let's go to the concrete mix design itself, and we can be specific to your previous example of a residential structure. What does that mix design look like, and how does it differ from your typical standard 3,000 or 5,000 psi concrete?
Yep. Well, I will need to do a quick conversion because I'm not really familiar with the PSI. I will just, let me do a conversion from megapascal to PSI. So the concrete that I'm currently working with has a compressive strength of 7,250 PSI. So it's quite a strong concrete material. The only difference between it and the traditional one is that it's, of course, it has special additives and chemicals that allows it to build on top of each other, because as you know, like traditional concrete is more fluid and it just kind of flows like water, more or less, depending on the amount of water that you add to it. But 3D concrete material needs to be more dry, and it needs to build on top of each other, so you can actually create the geometry. So that's the purpose of the additives and the chemicals in the mix. On another aspect, the size of the aggregates compared to the traditional concrete are much smaller. So to some people it could look more like a mortar material than a concrete material, because you're not really able to see the aggregates inside.
Okay. But there is aggregate there. It's just smaller aggregate is what you're saying?
It's very small aggregates, around 2 millimeters.
Okay. Well, I guess the water cement ratio would be I guess typically lower as well, because you said the mix isn't quite as fluid.
Yep,
but
much lower.
And then I would imagine your cement content is fairly high in comparison.
I think it's more or less slightly higher than normal concrete.
So the extrusion that you need for the concrete as it comes out of the nozzle when it's printed, you get those characteristics, those flow characteristics. You achieve that with additives?
Yes, well, that's also one thing to note, is that we ourselves, we are not, we partner with the material experts that manufacture the material for us. We work with Sika. I've been working with them for over the past 3 years, developing the material and testing it. So they're really the experts on this topic. But basically, the material that we get is a ready mix. It's in a powder form. Either we get it in 25 kilogram bags, or we get it in jumbo bags, 1.5 ton. And basically it's a ready powder. It has all of the additives in it that makes it 3D printable. We simply add water to it in the right amount and supply it into our systems.
So you are taking dry bagged material, mixing it with water on site, and that's how you're supplying the printer.
Yep.
So you don't have ready-mix trucks coming in and out of the job site. You have your supply of dry material that you mix down on site.
Yep. And the reason why it needs to be dry in comparison to a truck is because this material hardens fast, meaning that it has a high amount of accelerator in it, and you can't just mix it all together at once. It needs to be just mixed before the extrusion.
I'm going to attempt to ask this question. Josh, you may just cut me out and repeat my question if my voice is too messed up. But I'm curious to know, so you're mixing it on site. What are you mixing it in? And I'm assuming it gets pumped some way, shape, or form to the extruder. Can you kind of walk us through that process?
Yep, you just actually placed your finger on the most complex and the complicated part of 3D concrete printing, is that you want the material to set fast so you can build the layers very fast, but at the same time you don't want it to set that fast that it can not flow through the hose arriving to the nozzle. So this is the dilemma that we work with, and this is why the material part is very important, is that you want to have the material flowable enough so it can pass through the hose all the way to the nozzle, but once it is extruded from the nozzle, you want it to set fast. So this is where a lot of small details are really important, such as the water content that you are adding to the mix, and you really need high control over that. But basically, we have the powder coming in separately, and we have the water coming in separately. We have it mixed and sent through the pump into a hose that connects the pumping mechanism with the nozzle, and basically the nozzle is attached to our printer or robotic arm, where it makes the movements according to the programming code that we send to the printer, and the material is extruded.
The printer itself, the nozzle, how it's applied. Obviously, these shapes can be very intricate at times. So as far as how you place the concrete and develop a shape of whatever it is you're printing, you essentially have an X, Y, and Z axis like you do in every other 3D thing that's ever made. But how does that work? You have your robotic arm, so the robotic arm takes care of all three of those axes, or do you have a gantry that takes care of the X, or how does that work in geometry speak?
So, so this is what differentiates a robotic printer from a gantry system. So a gantry system is basically working with the XY coordinates, such as the desktop 3D printer that you're familiar with. However, the robotic arm works with 6 axes. So basically you have much more freedom in the range of movement, and basically you can really compare the robotic arm to your normal arm that you have on your hand. Is because you have the joints that can give you more control over all of the directions in six axes basically. And with the robotic arm printer, you don't really have to print horizontally every time. You don't need to print horizontal lines. You can start to print what we call non-planar surfaces. So you can go and print, the first layer is curved in this direction and then the next one comes on top. So it opens up also for more possibilities to print objects that are not emerging in a linear horizontal manner. And that's what really differentiates the robotic arm, is that it gives you more freedom in the additive manufacturing process.
Do you work with, is it G code? Is that what you're using as like the language there?
It's a robot code. It's a robot code,
Okay.
but it's kind of similar to a G code because basically it's a point map or point cloud, basically that defines that every point has a in a printer it's an XYZ, but with the robotic arm it's the 6-axis definition. So it's like three more coordinates for the robot to reach.
Right. Yeah, I'm sure it's way more complicated than what I deal with and what I actually think is complicated. You don't know what you don't know, I suppose, is what I'm saying. But let's talk about quality. I mean, you're talking about what you're able to do with the 6-axis system, and it's very intricate and very advanced. But let's talk quality, because if there is a dig from people of the unknown on the 3D printing industry, is that sometimes it's not always aesthetically pleasing because it's just stacked lines together, and obviously some prints look better than others, and it's that way with any type of 3D printing. But when you look at how do you hone in on quality, what are some things that you need to take into consideration if you want a 3D printed house to look better than, say, how do you make the prints look better?
Yeah. Well, there's a really good question, and to answer you, like I have I'll split it in two parts. In terms of quality, you have the quality that can address the structural integrity of the printed wall, and then you have the quality that can address the aesthetics of the wall. In terms of the structural integrity of the wall, is really vital to have always a structurally sound printed wall without any cracks, major cracks. I mean, any kind of cracks that will jeopardize the structural integrity and the stability of the wall. So that structural part is out of question. Like, you are not supposed to print something that has minor cracks and you're like, oh, okay, but at least we have a little bit of cracks, it should be okay. No, when it comes to structure, there's no messing about with that. Like, it needs to be structurally sound. You're only fooling yourself at the end of the day. But when it comes to the aesthetic, quality of it, then it's not really a structural element, but it's more like a visual element. So it doesn't really matter if it looks really nice or a little bit nice or ugly or so. But of course, the desire is to have a really nice printed layers that are consistent and can be left as a final finish for the building. So also the advantage of 3D concrete printing is that, at least to me and the work that I'm doing, is that the ability that I'm able to print a wall with a concrete material, a really nice finish, and I'm able to leave it as a final finish without additional plastering, without additional painting. And what that basically does is that it cuts out all of the additional labor and work that traditionally needs to be done in-house. So it accelerates it, saves the money, saves the time, etc. Now, on the other hand, if you have a finish that is not really appealing, you can simply finish on top of it with a plastering material to cover it up. And I assume at the end of the day, it will be a personal preference from a client's point of view if they want the lines to show or they don't want the lines to show. In some cases, even if the lines are the nicest finish ever, you might just have someone that just doesn't want to see the lines and will cover them up.
And honestly, I mean, that's the way the construction market is now, especially residential wise. I mean, you have some houses that are all brick and siding, different types of stucco. I mean, the options are endless. So, why shouldn't it be that way for 3D printing as well? But let's pivot a little bit here. I want to talk about your company, Print4D. You're based in Prague, correct?
Yes, in Czech Republic, yes.
Okay, all right. Well, we get into economics a decent amount in this show. We've had an economist on, and at the end of the day, we work for a company, and our goal is to make money, right? If it doesn't make dollars, it doesn't make sense. So 3D printing is cool. Yep. It's super interesting, but you own a business now. You own a company. So, who's your primary target? Who's your demographic? How are you using this 3D printing technology to make money?
Yep. Well, the reason that we situated, let's say, the company in Czech Republic is because the Czech Republic is a central country in Europe, and basically we're able to reach our clients, in the Middle East, in America, in Africa, within a reasonable reach. So that's one of the factors that we took into consideration. But today, over the past year, ever since I founded Print4D, I've noticed like a literal explosion in interest when it comes to 3D printing. And with more projects rising to the surface and people are able to understand the advantages of the technology and how they can utilize it for their own projects, we have received a lot of demand from clients all around the world that would like to implement this technology into their projects. So today what we're doing basically is we're helping our clients to achieve their goals in the fastest way possible by providing 3D concrete printing as a full solution to them. So they don't need to spend years researching and understanding how it works and what is the right way to do it. So we provide our know-how and expertise to them, and we sell the printer as a finished, let's say, hardware and software, and we do train them also how to print and how to use the equipment and how to design for 3D printing and all of that. So they're able to immediately start printing for their projects, within a month or so.
So your business model is selling printers and training your customers on how to use the printer for whatever application they may need it for.
Yep, exactly.
Is there a country that's kind of leading the charge in 3D printing? Is there one that has more of a demand for it, more interest of it, or more interest in it than anywhere else?
Well, the interest is more or less divided, I would say. The US is definitely having a big interest at the moment in 3D concrete printing. And the reason I think personally is that concrete is not the most common material to build houses in the US. which is different actually in other parts of the world. So in Jordan, for example, the Middle East, or Europe, concrete is the main material to build houses. So it's not that kind of an unfamiliar material. So in the US, it seems that it's like quite a new building material for houses. So there's also that element of novelty to the technology, which is quite interesting. But I would say the two leading countries today, and the reason they are leading is because the technology is supported by the governments. Is number one UAE and mainly Dubai, where I was working, and the Netherlands. They have the highest concentration of 3D printed projects in the world.
The Netherlands. I would have definitely guessed Dubai. I wouldn't have guessed the Netherlands. That's interesting. Your clients, the people that you're selling these printers to, what do they do primarily? Are we talking about construction companies that build residential houses, or is it something different?
That's also very interesting, and it's also something that continues to amaze me. Like when I meet with different clients, there is no real, common background where my clients come from. It could be some people that are involved in construction, some people that are in IT, they're working in IT, some people that are really far away from construction. So there's no real, specific group of people that are interested in this. And I kind of understand it, because with 3D printing, and especially the solution that we're providing to our clients, they can learn it. We can teach them. We can pass on the knowledge within 1 week of training, and they're able to start printing afterwards. So they don't really need to get involved into all of the complexity that we have experienced ourselves in the past.
1 week. 1 week. You can teach someone how to use
1
this thing
week.
in 1 week. That's amazing.
Yes. Yeah.
That is amazing, because heck, I'm still learning how to use mine.
Yeah. All you need is a small team of 2 or 3 to run the printer, and you're good to go.
Kind of wanted to jump back into the mixed design and how it relates to, you said you got clients all over the world.
Yeah.
Are there materials do you guys just have a certain standard of materials that, aggregates or cements or admixtures or whatever? Do you work with more local materials, and do they have to meet a certain standard or specification that you guys lay out? Or do you source materials? You said it was prepackaged. So do you source materials from one place, package it, and then ship it across, the world?
Yeah, again, we ourselves, we don't really produce the material. We work with concrete manufacturing companies that produce us the material. So those kind of standards, it's really it's the things that they're concerned with. But yeah, sorry, cannot answer that one.
You kind of did. So if you sell a printer to somebody in the Netherlands and then you sell a printer to somebody in the United States, they will essentially be working with local providers. For that mixed design that is specific to their application. You're not sending out the same packaged material from one location to everybody.
No. That's completely against our goal here. Our goal here is to localize manufacturing and to make it more sustainable. To ship materials across the world, it's just not sustainable, and it really doesn't make sense. So.
All right, so with all that in mind, I mean, you told us about how advanced these 6-axis printing machines are. You talked about how easy they are to implement. Within 1 week, they can be up and running to whatever application they're needed for, and they're used for applications that span everywhere from residential construction to prototyping to architecture and artwork. But what can we look for in the future? I mean, we're talking about a technology that is advancing so rapidly. What's on the horizon? What's on the immediate horizon? What's on the far horizon as far as what you've seen is possible for these machines and what we can look for?
Obviously, one of the biggest advancements that we're looking for is full automation of the system, because today still like there is a certain limit, a certain amount of human involvement in the 3D printing. Monitoring the material, monitoring the print, and so on. So one of the aspects that we are working on is making it fully automated. That you, as a human, you just literally, like today, it's literally pushing the button, but you need to monitor the printing and ensure some parts of the printing and the quality is to your standards and what it needs to be. But in the future, what we're trying to achieve is a fully automated system that you can literally press a button, go watch a movie, come back, you have it printed, similar to what a plastic printer, desktop printer does, if it decides to run well that day.
Heard that.
But, yeah, because I've printed with plastic and sometimes it just doesn't work.
Yeah,
but
for
yeah.
no apparent reason, you come back to a plastic tumbleweed.
Yeah. Exactly. So that's one of our goals, and second goal is that we want to scale up the technology that we are able to produce bigger pieces, faster manner, and to be able to print larger construction projects. And the third aspect is, of course, from the sustainable point of view. We understand that concrete and cement contribute to 8% of global emissions, and what we would like to do is to make concrete a bit more sustainable by probably reducing the amount of cement content and hopefully reducing the CO2 emissions by that.
Well, I mean, honestly, you guys are going to be, the 3D printing community, the 3D printing industry is going to be naturally reducing the amount of carbon emissions that are used on a job site, because you're going to have less people there. You're not going to have ready-mix trucks going back and forth to the job. It streamlines the entire process, and thus you're going to get a natural CO2 reduction just in that, without even looking at the mix design itself. So, you're doing great things there, just naturally. But right now, talking about the industry, it's been described by many as the Wild West, right? You have a lot of startups, you have a lot of new companies coming on board, you have a lot of not necessarily construction or concrete guys, but you have engineers, and you have people who understand these printers and how to evolve them. And right now it's, and correct me if I'm wrong, obviously, but right now the market itself for the 3D printing industry is a little bit scattered, and like I said, it could be known as the Wild West. So do you see a centralization of the industry or more of a consolidation?
Yeah, I mean, to be honest with you, like the way that it's looking for me is that of course you have the technology providers that understand the technology and the industry and can provide a solution for smaller, let's call it subcontractors, that they want to get into the concrete industry, either 3D printing housing units or other applications. So you have those service providers and the technology providers, and you have the small subcontractors. Now, it's not necessarily bad that you have the small subcontractors, because again, going to my point of localizing manufacturing, that could be a good thing when you have a small subcontractor close to a certain job site that can print your project quite easily and is accessible to you. So that's one of the good things that can happen. But also we should not mix up the technology providers with those subcontractors, because the technology providers are the ones that really understand the technology and provide it. And the subcontractors are mainly using it as a tool to get things printed. So what could be a bit confusing to people is that when you look at a subcontractor that is printing with this, you could also mix it up and think that, okay, they are the ones providing the technology. But that's the way it is. And I don't think it's necessarily a bad thing, and I don't think that larger companies will buy smaller companies. It's just a matter like, a subcontractor that comes in and installs your windows. It's going to be that way.
One question I did have in regards to, localized materials, do you think this is something that will expand into, say, the ready-mix industry? Do you foresee ready-mix suppliers, creating a quote-unquote 3D concrete mix design to supply jobs like this?
Yes, it's already happening. It's already happening. You have companies like Cimex, you have companies like Sika, you have Heidelberg Cement, for example. You have all of the big concrete companies that are already having their own mixes that they can supply to job sites.
In regards to that, say a ready-mix truck does, show up on site. What would be the typical load size for a 3D concrete job? For instance, would a concrete truck show up with 10 yards or 10 meters, or would it be smaller loads? And how long do you think they would be on the job site? Because that's something I hear about pretty often over here in the States, especially even this past week on some jobs that I was doing. The concern was, truck turnaround time and a concrete truck spending too much time on one job site when it could be servicing another. And they were also weighing out the benefits of volumetric, concrete trucks. So, in short, what would be a load size and how long would a concrete truck spend on the job site?
Well, here's where this technology excels in comparison to traditional concrete, because with 3D concrete printing, as I mentioned before, you have a dry mix, meaning that you don't actually need a ready-mix truck to continue, rotating the material and keeping it kind of fresh. You are able to install a silo onto your job site and basically have your dry powder bags just on next to the job site without the need of any truck, and you basically just unload that dry material into your silo at any moment that you want. So you don't need to have any certain truck waiting in the job site, and basically it's a completely independent solution.
This is where I'm super confident that volumetric concrete is the ticket to 3D concrete. I'm unsure. Do you guys have volumetric concrete trucks in Europe or other parts of the world that you've seen?
The ones the ready mixed concrete, right?
No. So volumetric trucks here in the States, they almost look like regular dump trucks, and they have individual bins and hoppers. They have, say, one side is rock or sand. Another bin is cement, and so they are actually metered into the small hopper on the back of that truck, and it is mixed via an auger with water and placed into a pump, or it could be discharged, just like right out of a concrete truck and onto the ground. But the advantage that they have is essentially what you just said. They can supply fresh concrete right then and there on site. The concrete doesn't continuously have to be mixed, in a drum. The truck can be stopped, and you can halt, production of that concrete, and make any adjustments that you may need to make on site with equipment or just whatever. And in the meantime, you don't have concrete sitting there setting up and getting old. And then when you're ready to start back up again, you can just crank that thing right back up and make completely fresh concrete.
Yeah, definitely. I mean, I haven't seen it around the world, to be honest. I haven't never seen such a truck. But as I mentioned, for 3D concrete printing job sites, you don't need a similar truck. You just need a low bed trailer with a bunch of bags filled up with dry material. You deliver them to the site. You unload them from the truck. If you decide to start printing 1 week after, 2 weeks after, that's not an issue. You just lift that bag, empty it in your silo, and start printing. So it's not really dependent on availability of the truck or the presence of the truck or whatsoever.
In instances where you're trying to print a large structure, is it possible to stitch two printers together, like code them together, where one printer is printing until it can't print anymore, and then another printer picks up the same print and continues along?
Yep, definitely. That's also one of the methods that you are able to use robotic arm printers, is that by on a larger construction site, you're able to implement 3 at a time, for example, and each one covers a certain range of motion, and they are printing simultaneously even, and that will even make the printing process faster.
That the possibilities are endless then. That's amazing. I think initially for our podcast, that is a fantastic synopsis of the 3D printing industry, its advantages, and what we can expect in the future. So to round us out though, Joe, ask the question that we ask all of our guests, because I'm interested to hear from Luai.
So Luai, you've been all over the world, with 3D concrete and printing. We have to ask you, what's the craziest thing you've seen on any of these job sites you've been to?
What is the crazy? Well, the craziest thing that I've seen is that when basically the printer is running and the team is just sitting down, having a snack, chatting, and not really being worried about the wall being built. So that was a bit surreal to see. That you're just leaving the job for a robot, for a printer, and you can just relax. So
it's a very good diplomatic answer for somebody who owns a 3D printing company. That's that is amazing.
I was going to say, I guess when you take more of the human element out of a project such as a 3D printed structure, that your crazy construction site stories are they're not going to be as wild as say when you have a legit job site going on in Florida like we've seen in the past.
Yeah, for sure.
Awesome. All right, Luai. Well, we will get you out of here on that. We certainly appreciate your time today and appreciate all the information you were able to share with us. And we're really looking forward to talking with you later down the road. The next big project or next big advancement that you have, always reach out and we'll be happy to talk about it here on the program. But we appreciate your time.
Thank you so much. I appreciate it. And it was a pleasure joining you guys, and hope to stay in touch and to chat with you sometime soon again.
All right, and that's going to do it for this episode of the Add 10 Gallons Concrete Podcast. We hope you guys enjoyed. That's something we wanted to do for a long time. And we hope you learned a little bit more about the ever-changing, incredibly exciting, and seemingly endless potential that is the world of concrete 3D printing. Be sure to give us a like and follow on our social media pages. That's Facebook, Instagram, and YouTube as well. Check all of our social pages for daily content. Tell a friend about the podcast. If you enjoyed it, give us a review wherever you get your podcasts, and be on the lookout for the next episode here on the Add 10 Gallons Concrete Podcast. Big thanks as always to our presenting sponsor, Acti-Gel 208. And once again, one final thanks to Luai from Print4D for all his wisdom that he shared on the podcast today. We certainly appreciated it. Until next time, y'all be good.